Okay, so we're in Fastad, and I'm just going to take a simple circuit. We're going to take a 10-volt source and a 1 ohm, a 2 ohm, a 3 ohm, and a 4 ohm resistor. And I'm going to show you how we can calculate this using Ohm's law, and we can also create the circuit in Fastad to verify our outcome. So I'm going to go to options, and I mean circuits, and I went to blank circuit here. So I'm just going to come in and I'm going to draw a source, and this particular source is going to be a 2 um, terminal voltage source. We'll go ahead and right click on it and make it 10 volts. Whoops. So there's our 10-volt source, and I'm going to draw some resistors now. I'm going to draw, these are going to default to 1K, but I'm going to come down and change them. There's another, here's another, back, whoops, I didn't put one there. I'll hit escape, control Z, and do a draw, add wire. So we've already got circuit flowing. We know we got this set to 10 volts. So I'm going to right click on this one and say edit. I'll make him a 1 ohm. I'll right click on this guy, edit. Make him a 2 ohm. Right click on this guy, say edit. Make him a 3 ohm. And I'm going to right click on, whoops, highlight him, right click on him, and say edit. Make him a 4 ohm. So, and you can see this thing's got a lot higher current. I'm going to slow our simulation speed down and our current speed. So I'm on, first we're going to do Ohm's law here. So we know this is 10 volts right here. And if we put our Ohm's law circle into play, that is, and sorry, I'm not an artist, particularly with a mouse. Um, erase that. Start over. I can do a little better than that though. Well, I'll do it without the circle, and I think that'll be a little easier. But we know it's V over I times R. And all we have to do is cover up what we're looking for. Well, obviously, we have resistance values, we have voltage values, we need current. But the very first thing we need to know is how much is our total resistance. In series, it's easy. Our total is the sum of each of these. So 1 plus 2 plus 3 plus 4 is 10. So our total is 10 ohms. So there's the little ohm symbol, best I can do. So we've got 10 volts because we got our voltage right here. So we can take 10 volts and divide it by 10 ohms. And that's easy math. That comes out to be 1 amps, 1 amp. So these little dots that are moving in our picture here represent our current flow, and that current flow is 1 amp. So because there's only one path, this is like water flowing through a pipe. 1 amp's going through our 1 ohm, 1 amp's going through our 2 ohm, 1 amp is going through our 3 ohm, and 1 amp is going through our 4. Now we also know the sum of these drops should equal 10 volts. So we're going to search now for the V of R1, and I'm just calling this one R1, this one R2, this one R3, and this one R4. So the V of R1, V of R2, the V of R3, and the V of R4. Well, we are going to cover up the V because that's what we're looking for. We're going to say I times R. So we're going to say 1 amp times 1 ohm. So this is a 1 ohm resistor. We have 1 amp of current flowing through it. So that's going to equal 1 volt. I'll have 1 amp through this 2 ohm. That's going to equal 2 volts. This one's going to be 3 volts. And this one's going to be 4 volts. I made this where the math was easy, and we'll do one in a moment, maybe that the math is not. But we're going to verify that we have that much current. So I'm going to get rid of my pen here as soon as I figure out how to cut it off here. Back to the mouse. Here we go. So we're going to take out this line right here, and we're going to, well, click on that line. We're going to say show current. And look at there, 1 amp. And that's exactly what we calculated over here was 1 amp. Now I can insert a voltmeter. I'm going to draw, and I know my writing's in the way, but I'm going to add a voltmeter. So get it lined up. So I'm just going to kind of put this voltmeter right here, and I'll show you why in a minute, because I want to measure across each one of those. Now when I first hook it up, it's going to be referencing to ground, which is this negative. I have to have both sides of this voltmeter across whatever I'm wanting to measure. So you'll see it change, don't worry about that. But I'm going to draw a wire across the left side and the right side. And look, we're measuring across this 1 ohm resistor, and we're measuring 1 volt. So I'm going to do a Control Z and get rid of both those. And now we're going to measure across this 2 ohm. And we're measuring -7. I see why I missed getting my lead right here connected. So I'm going to hit escape where I'm not drawing. And I'm going to move this lead back to my target. There we go. Now we're measuring 2 volts. So that was a whoopsie on my part for not getting that directly across. So we're going to Control Z and get rid of the 3 wires we added. I had to add an extra wire. And we're going to put 1 across this guy and 1 across that guy. And look, 3 volts, exactly what we calculated. I'll do an undo or a Control Z. It'll be a little harder for this one, I think, but hopefully we can scoot across there. And 4 volts. And it's measuring negative just because the orientation I've got. This is the positive side of my meter. If I were to reverse those leads, it wouldn't be negative. But we proved it, and we built it, and we checked it. Now, let's do one that's a little more, a little less, I should say, um, what's the word I'm looking for? A little more challenging as far as the math. I made this one where the math would work out very nicely for us. But let's, there should be a, yeah, garbage. Okay, got rid of my Ohm's law too. That's okay. So V over I times R is always Ohm's law. Now we're going to edit these values. I got to go back to my mouse pointer. There we go. We'll right click on our source, say edit, and we'll make that, let's go 50 volts. And we're going to right click on this first guy, and we're going to make him 10 ohms. Let's make him 100 ohms. Did that. And we're going to right click on, if I can ever right click, there we go. We're going to edit him. We're going to make him 50 ohms. We're going to right click on this guy. Again, I didn't right click. I'm getting mouse happy here. Here we go. Edit. Make him 200 ohms. Let's right click on this guy. Well, again, mouse happy. There we go. So, let's go. Let's make this guy 650 ohms. And of course, our current has slowed way down because our resistance has increased. I sped it up a little bit so we can see it moving. But we can apply Ohm's law to this circuit as well. So that's what we're going to do. Well, we know that this was 50 volts. So V total is 50 volts. So R total, we just got to add it. R total, add them all up. So 100, 150, 350. So that's 1,000 ohms. So 1,000 ohms or 1K, we'll stick with units. So now I'm going to have to bring up the calculator for both our benefits because I'm good at losing decimals here. let you see that. I'll put it on the screen so you can feel free to check it as well. So we're going to take 50 volts and divide it by 1,000 ohms. 50 divided by 1,000 equals 0.05 amps. That could also be expressed as 50 milliamps, but we're going to keep it at I equals 0.05. So we're going to check that. We're going to get our mouse pointer back. We're going to right click here and look at there. That's already 50 milliamps, and that's the same as 0.05 because basically we would move the decimal place 1, 2, and then to move it one more we'd have to have a 0, and that would be milliamps. So that checks out. So if we've got 50 milliamps of current, and let's keep the calculator over here so we can all see the math. There we go, it's coming up. So if we've got 50 milliamps of current going through this 100 ohms, it's I times R, 0.05 times 100 equals 5 volts dropped there. So let me get my mouse back, and I'm going to write it just inside here as small as I can, hopefully. And if I do the math on the next one, it's going to be, I'll let you do it, it's going to be 2.5 volts. And if I do the math on this one, it's going to be 10 volts. And got to do the math on this last one. I'll let you check that math if you want, but it's 0.05 times 650, and that is 32.5 volts. 32.5. Well, 32.5 plus 10 is 42.5. That's 45, and that's 50. So our math seems to check out. Now we're going to connect our voltmeter. We're running out of time. I don't know if we'll get to go across every one of them, but let's go. Let me draw some lines here. Let's go across our first one here, and we're expecting it to be 5 volts. When I get it all the way across, it is. Undo, edit, undo. Whoops. I'll try to do the next one. And sure enough, 2.5 volts. I'll see if I think we can get the last two here real quick. There's that one. And I got to make sure I hit those dots. Make sure you get the dots. There's 10 volts. Because I'm really not connecting to it if I'm not putting dot to dot. That's why I can go through the circuit here and cross my wires. Because if I don't touch the dot, I'm not really connected. So this isn't really connected right there. It's going above it or below it. But we're reading 32.5 there as well. So we have performed Ohm's law. We have proven Ohm's law using Fastad, and we can see it. So I want you to use both when you do your assessment, and that way you should get 100. If you don't, just because likely you either didn't understand the material, didn't understand how to use Fastad, or just didn't take the time to do it. So if you have questions, please let us know. But this is a great tool to build circuits in and to try things out with.